Welcome to part 3 of best practices in managing information technology. Today we shall be discussing about IT project management. Now, IT projects have distinct characteristics from operations. First and foremost, they have a definitive start and definitive end, unlike operations, which is continuous. In fact, the mere reason why they exist is to produce a certain product or output, which in IT we normally call a service. And last but not least, IT projects are inherently ill-defined upon the start, and they need to be successively defined and the scope refined as you go along with the project. IT projects have very distinct phases as you go along. You start with mobilization of resources and then analysis and design. And analysis and design is where you try to define the specifics of the deliverables of the whole project. Then you go into build or development, whether that is coding or defining configuration items, where you have the peak number of resources. Then you do the testing, you deploy into production, and then the number of resources slowly goes down when you enter the warranty and support period. The project manager is supposed to monitor and control the project from beginning to end using special tools as well as methodologies in order to do that. One of the most important dimensions of IT projects is actually scope management. And scope management in IT projects are inherently ill-defined from the very beginning. And why is that? That's because software is really an intangible, and it's very difficult to fully define what the software has to contain. In the same way, hardware is becoming more and more intangible nowadays because aside from the hardware itself, there's embedded software, firmware, as well as policies that are embedded in the hardware which make it unintangible. And so the irony of it is that although IT projects are inherently ill-defined, scope management or poor definition of scope is actually the biggest reason for failure in IT projects. The project monitoring and control can be done using some measures. The typical measure that is used is percentage completion of the project, so that you know the progress of the project versus the baseline. Right? However, project completion by itself is not a very good measure because it doesn't really tell you how advanced or how delayed is the project, and it doesn't tell you either how much cost overruns you have. And therefore, it has to be complemented by at least one or two indicators. The best indicator for monitoring the progress of a project is SPI in terms of percentage. And SPI can also be used to project when the project seems to finish based on the current rate of efficiency or inefficiency, something which is very helpful for the project manager in order to know when will it actually end. Now, these important measures, SPI, CPI, can be calculated in turn from things such as earned value and actual cost versus the planned value. So firstly, planned value is the value of the project. Let's say it's a $4 million project and that's the planned value. Actual cost is the cost that you are incurring. However, one of the most important measures is earned value, and that means not how much you've spent, but how much value does that project actually have for you. And that I will explain in the next slide. And from here, we can calculate the SPI and the CPI, and in turn, we can also calculate from the SPI how much time it will take to complete and by when. Now, in this simple example, I try to explain how earned value works. Now, imagine this is a $1 million project. So you can see the planned value being projected over time, eventually to reach $1 million. However, because this project is not uh, fixed contract, it's time and materials, the actual cost also evolves with time. In this case, you have overruns in terms of cost. At the current time, T5, we can see actual cost has actually increased to $600,000 versus what was planned, which was only $400,000, right? So that means that you're over budget. The earned value means how much of the work was actually completed versus planned. At time 5, we estimated under the planned value that 400,000 worth of deliverables would be finished, which means module 1 would have been fully tested. However, we can see the earned value points at 200,000 value, means to say we've only finished the functional design. And therefore, even though we paid more, the actual value of the project to us is only worth $200,000. This is a very important concept because earned value can be used to measure the actual progress of a project versus the plan. Now, here we have an example using a project management tool to view the progress of a project. In this case, the project is 84% complete, as we can see. But let's go further and investigate how well the project is going. As you can see here, even though 84% complete, the SPI of the project points at 88%. That means the project is 12% delayed versus the plan. And that also gives us an idea of when we will finish. Now, using simple tools like this for project management, we can actually monitor both the status of the completion as well as project on when the project will actually finish and whether it has actual cost overruns. If the project is having issues, then what we would do is go to the issue registry, which is a simple Excel sheet, which itemizes all the different issues that have been encountered and the status, whether it has been resolved, it's still open, and the action that has been done in order to resolve it. So with such a simple tool, we can actually manage projects pretty efficiently. Project documentation is also very important, and the reason why it's important is for various reasons. One of them is that when the project ends, it has to be passed to operations, and operations needs documentation in order to know how to support it. Secondly, the project may undergo change requests, may undergo another phase, so it's important to be able to record what has been done in order to take it up for the next phases. As mentioned in the beginning of this course, IT projects are inherently ill-defined in terms of scope, and so it has to be successively defined and refined, and that holds true as well for the documentation. So you have to start with very general documentation and then get down to specifics. So typically, for example, for the functional part of an application, you would start with the business requirements from the users, which are very broad and general, and then go next to the process design, start with a level 1, which is very conceptual, then level 2, which talks about sub-processes, and then finally level 3, which defines the specific transactions needed for each process. From there, you come up with a functional design, and each of these phases and each of these documents is signed off. And once you have the functional design, then that's given for development. And the final and level 4 of a process would be the user manuals, which refer to the specific instruction level guide that the users need in order to execute. And so here, we've gone from a high level to the specifics, and the most specific is the user manual. This is an example of a level 1 process documentation. This is an example of a level 2 process documentation. We can see the sub-processes defined as well as who is in charge of that particular sub-process. And this is a level 3 process design. We can not only see the sub-processes, but we can also see the specific transaction name which executes that particular process. Okay, that's all for now. If you want more information, please refer to my book, Managing Information Technology, available on the Springer website as well as Amazon, Google, and other online bookstores. Thank you very much. See you soon. Bye.